Hey guys, what is up? This is Ayush Singh Negi back with yet another video. And yeah, I sound really happy, right? Because we have hit 100 subscribers right now. So yeah, it feels surreal. When I started, I didn't really expect we would hit 100 subscribers so soon, but it feels really good. And I am trying to carry out this as much as I can, trying to improve along the way, taking all your inputs in. All your feedback is appreciated. Thank you so much, guys. I really appreciate it. And without wasting any more time, let's get into it. So today it's another video about DOSBox. I mean Tasm assembly language 8086 on DOSBox. So what we're going to do is basically, firstly, we are going to study what the problem statement is. So the problem statement is that we want to enter uh, two numbers from the user, okay, and they can be any numbers from 0 to 9, any number. And the other thing is that we want to print out the addition. So what we're going to do is we're going to write everything and we are going to display it. So we'll take the first input, the second input, and at last, after the third message, which is the result, we'll print out the result. So yeah, let's go. Okay, so to get into it, we'll type out edit first because as you know, like I'll just get into full screen. Yeah, I hope it's visible right now. So the first thing that we do is we press edit to get into the editor. So as usual, we'll take our model small. Then we'll take data, and we write what the data is. So firstly, our first message will be um, so M1 is message 1 data byte, and 10 comma 13, as we discussed before. 10 comma 13, 10 is line feed and 13 is carriage return. Now what is 10? Line feed is going to the next line. It helps us go the helps the cursor go to the next line. And carriage return is it gets to the starting of the line. That's what it does. So here's the message that we'll type. So enter the first number, dollar sign, close. That's the first message. Then M2 message 2 data byte, 10 comma 13 comma again the same thing. So enter the second number. Yup, it does feel better when you are getting such positive responses from your viewers. So yeah. Then M3 again data byte, 10 comma 13 comma. Lastly, we are going to show what the addition is. So addition is, and yeah, dollar. Then we move on to the code. Now that we have entered whatever we want to firstly display, we are going to write the code of how we want to manipulate whatever we want and get what the result is. So firstly, we're gonna display the firstly we're gonna move all the data into the data segment, as we're gonna need to use it later on. So MOV AX, the primary accumulator where all the data is stored, will be stored. So we are moving the data into the primary accumulator, and from there we are moving it to the data segment. So here we go. Okay, done. Now what we are going to do is basically we are going to execute the first message, that is enter the first number. So MOVAH comma, as you all remember, 09H. You can all pause the video and try to do this all yourself, how to write the output command and how it's executed, and how to take an input from the keyboard and everything like that from the user, I mean. So I'll wait for a minute, or you can just pause the video right now and then we can move on ahead. So it's great practice. The more you practice without looking at this, the better it will be. So the next thing, I'll just resume now. lea dx comma m1. So now we are using the pointer one. Like I remember I told you that MOV and LEA have a significant difference. That MOV will load the value that is there, but LEA will point towards the pointer. Will like load the pointer basically of the value. Like MOV will load the value that is there at that space, but LEA will point to the pointer of that space. Will load the pointer of that space. Sorry. So M1 will be loaded in that way, like a pointer. So I mean DX. Sorry, DX will be loaded in that way, and then int 21h. Okay. So int 21h, as usual, you all know, is for execution of the functions. Mov ah comma 01h. This one is for a string. This is a string function which is for accepting a character, for a character input. So we'll execute this one. So in 21h we are done. So okay, one number is accepted. Now as here we took the m1 input, and here we took m1 sorry, here we displayed the m1 message, and here we took the m1 the input of the first number. So now what we are going to do is, now that we have accepted the number, I would like to show you all something. So I'll just get over here. As you can see, I think this screen is not much visible, but you can see this. The numbers, that this is the ASCII table. So in ASCII, the numbers are a bit different. Like here, as you can see, the numbers from 0 to 31 have no character value. From 32 they start. So now in assembly language we use hexadecimal. So in hexadecimal values 0 to 2f have no value, have no like numerical value as such. They have only special characters. Until 1f there is no character value only, and from 20 to 2f there are these special characters. So now we are moving to 30. From 30 to 39 we have 0 to 9. Okay, so now what we want to do is, we don't want to play with the hexadecimal value, we want to play with the actual decimal value, hexadecimal value, sorry. So what we are going to do is, we are going to subtract 30 so that we get the actual value. Okay, so like supposing if I take the input to be the number, the character 4, that's the input I gave, right? So it will actually be loaded as hexadecimal value of 34. So now to get the value of hexadecimal 4, what we need to do is, we need to subtract it with 30. So I'll just do that. Okay, again I'll have to full screen. Yeah, so as you can see, so firstly we will do one thing, is that we will move the value from AL to BL, so that we can free up the accumulator once again, and we can do all the things that we want in the BX register for the calculations and everything. So now we subtract. So sub is for subtraction. So BL and 30H. As usual, the numbers are written with H. So 30H. So 30 will be subtracted. Now we need to check. Okay, so we don't know if the number, like we logically would be able to know, but the computer doesn't know. So to make the computer understand that the number is actually between 0 to 9, right? We need the number between 0 to 9. So how to make him check that? So firstly we will do a comparison. We'll use the CMP function. So BL comma 09H, then 0 to 9, right? So this will compare BL till 9. So BL could be any number. Okay, then we will check if the comparison is BL is less than or equal to 9. Okay, so if it is, so JLE, J less than or equal to, jump if less than or equal to x1. Okay, now x1 is a label that we'll jump to. Agar if this condition is correct, then we will jump to x1. Now we haven't defined x1 yet, please don't worry, we will define it down the line. So if it is not between 0 to 9, then we will need to subtract 7 from it. Now why sub 7? Why 7 exactly? You will get to know, because one second, I'll just show you. So I'm writing 7. Okay, we will need to subtract BL say 7. So I will just show again in the ASCII table. Now in hexadecimal, after 9 we have A, B, C, D, E, F. Okay, so we have 6 alphabets. Yeah, we have 6 alphabets. So actually 7 places are occupied till 10. Okay, so if someone by chance enters 10, so how will you get to check that? So in that manner we'll have to subtract it by 7. So that's why we are doing that. Oh sorry, yeah, so that's why we are doing that. And now what we are going to do is we will be defining the x1 label. So as I was saying, we are done with oh sorry, yeah, we are done with the subtraction now, and everything else, comparison as well. Now we were jumping if it was less than or equal to this. So x1, oh sorry, now move AH, 09H. Okay, so the first numbers are related, everything is done. Everything related to the first number is done. Now we are going to the second number. So now LEA, again the same thing, LEADX. You can pause the video and repeat whatever is necessary till the input and till the input function. So go on ahead. It's better practice if you do it yourself. So DX comma M2, second message is displayed. Then in 21H to display the to execute the function. Then MOV AH comma 01H to accept a single character function and to execute it. 21H. Okay, we are done. Now what we need to do is, again we need to take it from AL, the because it was in the A register, and move it to the B register. So what we are going to do is, instead, because BL is already occupied, now we are going to put it inside BH, because the register BX is divided into two registers, right? 16-bit registers are there inside the 8086 architecture. So we have BX, it will be divided into BH and BL, right? So right now BL is occupied with the first number, so we need to put the second number inside BH, right? So here's what we'll do: BH comma AL, then we subtract 30 from the second number as well to get the original number 30H. Okay, no sorry, yeah. Now that that is done, what we need to do is we need to display the result. Okay, we are not doing the comparison here because it's not required. As you can see, the second number, even though the comparison is already done, we don't need to do it for the second number again, because of only the first digit we will be checking that way. The second number we won't be checking it that way, because if one of the numbers is checked, then obviously the second number won't be exceeding the limit. Like, I'll just show you. So if there is a total like limit to how many numbers we have, like 19. So if the first number doesn't exceed 9, then we won't need to worry. If the first number doesn't exceed 9, then we don't need to worry only that the second one might, because there's nothing as such related to that. So we don't need to worry. Okay, I'll just go full screen. Yeah. MOV AH, 09H. Okay, then we display the third message, LEA, sorry, DX out of habit, DX comma M3. So the third message is being displayed, int 21H. Now, after the result message is displayed, now we are going to do the addition. So add BL comma BH. From both the registers, the value has been taken and added. So now whatever has been added, now we need to add, like, due to the letters being present in that particular table, so in hexadecimal value, so we need to convert it into as proper value. So what we are going to do is, first, to display this value, we'll need to move it to the data register. So mov dl comma bl, as the result was stored into bl, so we'll move it to dl now. As for displaying, it is necessary to display from dl itself. So as you might have noticed, everything is from dx, 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 and dl. So only the data register can display everything. So dl comma 30h. Okay, so now we are adding 30 so that we get the normal value, and then we do the comparison. Okay, cmp dl comma 39h, if the number lies till 0 to 39. Okay, 39 is 9. I'll show you. 39 over here is yeah, here 39 is character 9, so no need to worry about that. We are just checking if the number is between 0 to 9. After that, what we'll do is we'll jump to the second label, x2, if it is less than or equal to 0 to 9. So yeah, if not, then we add dl 7h, 07h, which means we will be adding the 7 to it to get the real value, which is whatever number it might be. So we'll get that number in that sense. Okay, like the 2-digit number, whatever it might be, because it is not from 0 to 9, right? So yeah. Then lastly, what we need to do is the second label, which is x2. We'll move ah from there to and 0 to h to display the number, whatever it is. Single character displaying. We can do a multiple character, but I didn't do. Even the number is taken in single character only, so no need to worry in that. So then what we do is, now we need to terminate it. So I hope you all remember the like function for terminating the process, which is 4ch, ah comma 4ch, and int 21h and end. With 0 to h, we can display the result, as you all remember, right? Like in the last addition problem, we had done that. So we can display the characters, whatever they might be. So yeah, that's about it. I'll just save it. Save as, add 16.asm, done. So I'll just okay, we have a file like that. I'll just rename it then 24.asm. Okay, in file, exit. So now what we need to do is, like always, how we executed the ASM code. So first is Tasm add 24.asm. No errors. Yay, be happy. Next, what we do is the linking to start the turbo assembler. So here we execute the object. So it started with no problems. Lastly, we execute. So add 24.exe. enter the first number. So our first number, let's say, I'm going to enter 7, and the second number should also be 7. So the result should be 14. Oh, E, sorry, not 14. Yeah, let the letter E. Okay. So yeah, that's what we get. And as in the ASCII chart, we can see the value E is given to 45, right? So when we, because of the presence of these values, we need to escape them and add 7 to it. So after 9 we add 7. So after 7 we get how much? A, right? So like let's say what we did was 7 plus 7, 14, right? So 1 2 3 4 5 6 7 8 9. Then we skip, then we take 14. So let's skip 7 first. 1 2 3 4 5 6 7. We skipped 7 and now we are on A. So 1 2 3 4 5. So E, and the answer is absolutely correct because the value that should be coming of at 14th value is E. Now we will take another example, like let's say we want G. So the value should be 16, right? So we have to do 8 plus 8 then. Okay, I'll just take it full screen. So again add, okay, I'll just, yeah. So first number 8, second number 8, answer is G. Very good. So it's working. So yeah, I know this was a short one, and I don't know how short it was as I'm recording right now, but I hope you really enjoyed this tutorial on how to add and like accept values and then add them and display them. So yeah, I would like to conclude by saying that thank you guys so much for subscribing to my channel. It means a lot that 100 of you found my content useful to you, and please do keep supporting me. I will bringing you more such videos, technical related or otherwise, like my FIFA one or my cricket 19 one or another game perhaps. So please do keep supporting me. Thank you so much. I hope you guys enjoyed it again. And this has been Ayush Nehi. Please do like, share, and subscribe on my channel and ring the notification bell. And I'll see you guys in the next one. And bye bye.